So in probability 12A, we're going to look at something called tetrahedral die, and some people think that the only kind of die are standard six-sided die like this one, but there's all kinds of different kinds of die. In fact, I have right here, it's a tetrahedral die. It's actually like a pyramid. It's got four sides with numbers. It's kind of hard to see, but you can see that the numbers on this one are listed so that when it lands, you can tell, like this case, a 3 would be the number when it lands because that's the way it lands setting up, and you can kind of see the 3s on all sides there. So when you roll it, it just kind of rolls a little bit differently. It doesn't roll very well, but it still works the same idea, is that you have a die and there's numbers on the sides and they come up a certain way. So that's tetrahedral die, like a pyramid type of shaped die. So if we were to roll die like that, and like we did the other ones, add their sums together, the two die together, and just fill in the chart, and then we can look at some probabilities. So the 1 plus the 1, and the 2 plus the 1, and 3 plus 1, and 4 plus 1. So you can see we're not, with four-sided die, we're not going to have as many different sums as we did with six-sided die. 2 and 1 is 3, 2 and 2 is 4, 5, 6. Again, just following the pattern in the table. Going to speed things up a little bit. 3 and 1 is 4, 3 and 2 is 5, 3 and 3 is 6, 4 and 3 is 7, and then the last row, 5, 6, 7, and 8. So you can see that with this type of die, there are only 16 possible sums when we take two die together. And so we can use that, again, to determine some probabilities. So if we look at the probability of getting a sum of 3, there are just these two ways out of 16, or 1 in 8. We reduce the fractions always when we have the opportunity to do that. So now we kind of go back to some of our other symbols, like this symbol, which means not. So the probability of not getting a 3 would be all of the rest, all these other ones, all but those two, which is 14 of the 16, or reduce that fraction to 7 out of 8, which again, if you look at the 1/8 and the 7/8, so we have the rest of them. So again, if we just look at the probabilities here, the probability of getting a 10, well, it should be obvious that with a four-sided die, there are no possibilities of getting a 10, so it's just 0 out of 16, or you could just say 0. There's no chance getting a 10 with this. Now the next one, less than 12. Well, of course, if you look at all of them are less than 12. So that's another easy one, that all of them, 16 out of 16. Or we could just say 1. Probability, remember, is a number between 0 and 1. In this case is the 0, in this case is the 1. 100% chance. It's certain that you would get something less than 12. And then we're going to look at some special cases, in this case even numbers. So if we look at the even ones, we have 1, 2, 3, 4, 5, 6, 7, 8. And if you think about that, that's half of the 16 are even, which kind of makes sense that we would have half of the numbers, 8 of the 16 are even. And then some of our special cases, the AND case, which means both of these have to be true. So if we want something that's even and more than 4. So look for even ones that are more than 4. So that doesn't count because it's not more than 4 even though it's even. And none of the 4s count because they're not more than 4. And so the first ones that count are the 6s, 1, 2, 3, and the 8 are even and more than 4. So 1, 2, 3, 4 of the 16, which is 1/4 of the outcomes, are even and more than 4. Now, we've said this in a previous lesson, the AND statements always give you less because they're more exclusive. Both things have to be true for an and statement, and so it usually reduces the number of possible outcomes. Whereas an or statement always gives you more, because in this case we can have anything that's even or more than 4. So we're going to take all of the evens and anything that's more than 4. So if you look at this case, that one's even, these are even, and then everything else is either even or more than 4. So the only thing that's excluded in this case are the 2 3s. Everything else fits into the description of either even, these are even, 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 or more than 4, which is the 5s and the 7s. So we have everything, 14 of the 16 are even or more than 4, which reduces to 7 out of 8. Again, or gives you much. Either of these could be true, and so we get lots more possibilities with the or statement. And that's 12A.